All right, hey everybody, welcome to our brown bag. I'm Amanda Witt. I am a product manager on Niantic's AR team, and I'm going to take you through ARDK, some of its key functions, and we've got Kelly and Max here who are going to dive in, and they're going to show some fun demos of using key ARDK features. Okay, so let's go in. Actually, let me pull up. Yeah. Okay, don't put it on laptop. Okay. Okay. Okay, cool. Let's see, okay, yeah, all right. Getting back into it. Quick look at the agenda. I'm gonna give an introduction to ARDK, and then we've got Max and Kelly who are gonna go in and show us some cool demos of our virtual studio and our game board feature. And then we'll have some time at the end for Q&A. So quickly, what is Lightship ARDK? In short, it's a set of tools and services for creating more immersive, realistic, and social AR experiences, and also for fusing AR content with the real world. It's also built on top of Unity, so it's written in C#. This is going to allow you to pull in ARDK services directly into your Unity projects. It's platform agnostic, so build once and deploy to both Android and iOS. It's also available and free to download and use at lightship.dev. So a little bit of background on the ARDK. ARDK was born from building AR experiences internally at Niantic. So we're taking elements from our games like Pokemon Go and Ingress and Pikmin and Bloom, our developer tooling that was used in the making of those games, and we're now making that available to our developer community. And the goal for ARDK is to make building AR applications simpler. We are abstracting some of the more difficult parts for building in AR, working with ARKit and AR Core. And then we're also bringing in some new advanced AR features, so real-time mapping and multiplayer and VPS, all for creating more immersive and real-world AR experiences. So I'm going to go into those key capabilities. And let me preface this first by saying there's a lot of topics here, and we've got talks that are going to focus in on each of these. But I'm going to provide a very brief overview. So a key capability to know is real-time mapping. So that is building out an understanding of the surfaces and the topography of the space. So building out that machine-readable 3D model. You can use that for better physics or occlusions or more natural AR experiences. And then also just for better modeling within the editor. Another key capability is shared AR. So we're bringing in our networking services in with AR, all for keeping gameplay, interactions, the virtual content all in sync, all in real time. Semantic segmentation is going to be that ability to identify and segment out different elements that are in the space. So things like trees, grounds, buildings, water, these can all be identified, and then that can be used to either position the content or control how that content behaves in that space. And then VPS, this is a very new capability for ARDK. There's actually going to be a talk that's going to go into the details of the visual positioning system right on this stage after this talk. But this is that ability to localize a user at a certain location, also persist AR content at that location so that we can really bring to life AR in the real world. I want to also quickly touch on the tools and resources that are available in addition to the core APIs and services. So a few quick things to know. ARDK and Lightship.dev offer tons of sample code and examples for you to use. So you can pull this right into your Unity projects. We've also got an end-to-end sample app, AR Voyage. We are doing some demos with AR Voyage that are out on the balcony, and then you can also download this from the app stores. We've got tons of learning materials. So you just saw the launch of lightship.dev/learn, but yeah, tons of tutorials and videos and step-by-step guides for you to learn ARDK and learn how to use key features of ARDK in your game. Virtual Studio, Kelly Cho is going to talk about this. So this is our in-editor mocking tool set. It's for mocking and editing right within the editor. Very cool tool. I'm very excited to have Kelly share that. And then we also have community tools. So visit us on lightship.dev. That's where you'll find our documentation and all these samples. But then also please check out our Discord. So I have the link here. Join us there. There's a lot of fun conversation happening, sharing of ideas, sharing of feedback, and really discussing all things Lightship and AR. Okay, so that was the very brief overview. I am very excited to introduce Kelly, who has been key to driving the development of the Virtual Studio feature set. So I'm going to invite Kelly on the stage, and she is going to walk us through Virtual Studio and show us a demo. Yeah. Okay, I'm going to pass it to you. Let me just get rid of this here.
Hi, my name is Kelly. I'm an engineer on the AR Unity team at Niantic working on the Lightship SDK. I've been at Niantic for about 3 years, but before then, I myself was an AR developer working at a startup here in San Francisco developing an AR app. And that was right around the time that ARKit was first released. So AR was still a very new technology. And back then, the app development cycle daily looked a little like this. So if I wanted to debug something, I would have to make the change to my code or asset, wait for it to build, wait for it to deploy, scan my environment to find the planes or feature points, and then finally, I could probably see the effects of my change and try to debug. But debugging is never as simple as we'd like it to be. So I would go through this cycle multiple times, not just in a day, but multiple times in an hour. And so I'm sure all of you understand the pain of that, of the time wasted and just the context shifting required in this cycle where you have to deploy onto a device. So back then, and still now, there is a tool called remote deployment to help address that issue. And so remote deployment is when you have an AR app on your device that connects to your Unity editor and then streams AR data back to the editor. And this is good. It works like it's supposed to. But there is still some friction in this cycle. You are tethered by the USB cord to your computer, so you have a very limited range of motion. And also, you're limited by your physical surroundings. So if you had an AR application that was meant to be played outdoors, like Pokemon Go or Peridot, you want to use semantic segmentation of the sky and water and grass and foliage and all that, you can't test that sitting in an office, waving your phone around your living room. Virtual Studio mock environments attempt to address some of those issues by supporting 100% in-editor development using mock environments that surface AR data to your code exactly the same as on device. So obviously, you want to deploy onto a phone eventually to play test your app. But for debugging, for tweaking values, and just generally making sure that your code works before spending the time to deploy it onto a device, 100% in-editor development is really the seamless way and the best way to do that. Just a quick overview of what features Virtual Studio does support in editor. So we have the basic AR features, so plane detection, hit testing against those planes, and image detection. And then we also support Lightship's awareness features, so depth estimation, semantic segmentation, and meshing, all in the editor. Yeah, but the best way to show you how Virtual Studio works is through a live demo. So let me jump into that. So for a little context, this demo was originally supposed to be about how to set up mock environments. It's hint, hint, it's very easy, et cetera. But actually, like Amanda mentioned earlier, we've got a lot of new documentation and tutorials available now on lightship.dev/learn to show you how to do that. So today is more going to be a demo of Virtual Studio in action and how it could help improve your workflow. So let's jump into it. So I've got a scene open here, very simple scene. Just going to launch an AR session with horizontal plane detection enabled. And I've also got a small script here to do hit tests against those planes and spawn this Captain Doty prefab if the hit test is successful. Pretty simple, yeah, but nothing is ever guaranteed to work perfectly the first time around. So I want to test this in the editor before I deploy it onto a device. So I can just enter play mode, and I have the mock environment available right here. The planes have showed up, and I can hit test against it and spawn Doties. Yay, the code works. But if any of you have tried out the AR Voyage app that we've got demos of here at the conference, you'll know that Doty is supposed to be a little larger, the size of a small child maybe instead of a cat. So I'm in the editor though, so it's super easy for me to just select one of these characters and then scale it up to the size that it should be. So let's try 4. OK, that's way too big. I guess 2. Yeah, that looks better. Yay, and then now that I know that the scale of the prefab should be doubled, I can just go into the prefab, change that, test it again in the editor if I want to, just to make sure, and then be pretty confident that when I deploy onto a device, my scene will be working as intended without any glaring, obvious issues. Great, and then, yeah, that would have taken me maybe half an hour to do without Virtual Studio. One build to run it the first time, realize that Doty was the wrong scale, another 5 different builds to test Doty at 5 different scales. But instead, that took 2 minutes. Yeah, OK, so let's jump into a different example. So like I mentioned before, Virtual Studio supports context awareness features in editor. So if you jump into any scene in the editor that has defs enabled, like the def scene and ARDK examples, you can see that in action. OK. Yep, and there we have occlusions. So a quick thing that I want to highlight here, in the Unity editor, your camera texture and your def buffer, and your semantic segmentation buffer, if you have that enabled, all of those are surfaced to the AR frame exactly the same as they would be on device. So we made sure to do that so that if you were developing any AR rendering features, you could also develop it right in the editor and be reasonably confident that it works the same on device as it does in the editor. But I say reasonably, though, because as you can see better when I turn on the debug def view here, the defs in the editor are they're too perfect, There's no noise, the edges are too sharp. This isn't a very close representation of the kind of messy defs that you would get playing this experience on a phone. And so we could try to replicate that noise in the editor, but instead, this is my segue into teasing a new tool that we have to address this issue and some others. And that's something that we call playback. So let me just show that in action. To this scene here, have playback enabled. And then ta-da, this is a recording of an AR session being played back in the editor. And in this scene here, we have meshing running but you could also have depth and semantic segmentation, and even VPS localization, all running in the editor off of real AR data. So yeah, we're very excited about this tool because it really is the best of all worlds. You get real AR data being played in the editor, and you can have data sets from all sorts of different environments, different environments and different lighting conditions. And that's really important to really battle testing your AR application. Of course, mocks, as I've talked about all throughout this demo, they are very important as well. They have a solid place in the Virtual Studio tool suite. They are more flexible than playback data sets in certain ways. You can create mock environments with edge case scenarios like a house with really high or low ceilings that you might not have a playback data set for. But playback is a tool that we're building in addition to that, that we're very excited about bringing to Lightship soon. And we would love feedback from you, our developer community, on what you would like to see from it or any other tools in ARDK that could help improve your developer workflow. And then speaking about such tools, another really cool one that was added recently is Gameboard. So next up is Max to speak more about that.
Okay, hello. Thank you, Kelly. Hi, I'm Max. I'm working for the ARDK team as well. And I'll talk a bit about a feature we call Gameboard that we just introduced with ARDK 1.3. It came out of research, and it is a high-level interface on top of what we call meshing, what you already saw a bit here, to give you a chance for procedural gameplay, because when some user pulls out their phone, you never know where they want to play. Maybe it's indoors, maybe it's outdoors, maybe it's a big open space, maybe it's a smaller space. So Gameboard is able to provide you navigation features and spatial queries on top of the mesh. And here you can see I can let Captain Doty run around my backyard, and I can tap on the screen and make him walk around with Gameboard. So how does it work? Gameboard is detecting flat surfaces on the mesh. And whenever we discover these, we add these green tiles. And they show us that we can use these tiles for navigation or for placing something, for procedural spawns maybe of items or enemies. And here you can see I use it for placement first to place Captain Doty. And then I can tap on these tiles to make him walk around. And he can even jump on the table. So this was the example that we ship with ARDK examples, and I'm gonna jump into this example scene and add some gameplay to it live here. This will also show you how we use mock tools to iterate on gameplay quicker than, as Kelly said, without deploying to the device to change some settings, trying it out in the editor. So let me go into the Gameboard scene. This is what we ship with ARDK 1.3, so you can get the same scene from our website. And let's have a look first. So we've got a simple script that just generates these tiles on the mesh. You can set the tile size, for example. You can set the tolerance, what we call a flat surface. You can set the scan interval, how often should it update per second, and all of these things. Just one script is driving all of this. And as I said, it's running on top of the mesh, so we have an AR Mesh Manager as well. And because I want to try this in the editor without having to deploy all the time, I'm using what we call the mock mesh system, where I can load sequences that I recorded beforehand. And I can use this prefab that we provide, which is called the mesh loader. It is already set up to use a mock mesh sequence that we record and ship with the ARDK examples package. And let's have a look what this looks like. So when I press play and start the AR session, this is being loaded into the game. And it's a sequence of 3 meshes, so the mesh builds up over time just as it would in a natural session. And you can see that the Gameboard feature works in editor as well on top of these meshes. So now with WASD and the trackpad, I can move around with my camera and detect these surfaces around the player. And I can do exactly as I did in the backyard, place Captain Doty and use the navigation feature in the editor. So this makes it easy to develop new gameplay just in the editor. And I've come up with an idea what I want to show you today. So I prepared a script called the coin generator. I just want to have procedural coins spawn in the, on top of the game board. And there's always going to be 1 coin, and when I collect it, a new coin is supposed to spawn. Let's have a look at the script that I prepared. I'm using the spatial query system of Gameboard here, where I say, first of all, is the game board big enough for my gameplay? Did I discover enough flat surfaces to play? This is in this if statement. Then, if so, find a random position on the game board, and I'm going to check second, is it far enough away from the agent because I don't want to spawn the coin on top of the agent? And third, does the coin actually fit this proposed spawn? So I can set a coin size, and the game board is going to check if the tiles fit this coin at the position. So let's have a look if this works. I'm going to press play again and discover some game board tiles. There the mesh comes in. I'm going to discover some tiles. Let's place Captain Doty, and I'm going to activate the script. But you can see I don't see a coin. So let me change the coin size. So in editor, I saw that my coin size was just too big, and I can change it at runtime and immediately see that the coin now spawns. So let's try to collect it with Captain Doty. Great. And so this worked fine. I can just change the settings at runtime and not have to deploy, find the bug, what's happening, what's wrong, what's right. So this is great. But I just tested this in this indoor setting, and I can now show you where to get these mock environments. We have a collection of them, and I can quickly show you a slide where we have the download section. If you can go to the slides, or not, there we are. So this is one example of a mock environment that we can give you. We try to get a collection of different environments, outdoors, indoors, big, small, something like that, right? You can see here on the left, you can see 3 trees, and on the right in the mesh, you can see the 3 trees. Perfect. And you can just go to the ARDK website where you normally download the ARDK. And we have a package here. It's a Unity package. You can get it. It's also possible for you to record your own sequences, no problem. But this just makes it so easy for you to pick up the stuff that we recorded already, just to get your first iterations out there. And after that, you can go on the tutorials, find out how to record your own meshes, but this is the easiest way. So let's jump into the demo again. And I already imported this package. I can show you how it looks like. Let's see here. So we've got 5 environments in here. Let's jump into this one. I'm going to reveal it in the Finder so you can have a look at what it looks like. Because we actually provide you also pictures of what the meshes look like. This is one collected with the Pixel 4a. So this is a low-end device, no LiDAR. So we have this one, and then you can compare it to another one that we. So this is the environment as a picture, and then this is the much cleaner version with the LiDAR. So we provide both of them for you, so you can try out, is it working on a high-end device, and is it also working on a low-end device without a LiDAR where we just have depth estimation and not real measurements. So I'm actually gonna select the low-end version just to show you that this is not a problem for this gameplay. I'm gonna right-click, copy the path, go to the mesh loader, and just paste the path in here. Let's have a look if this worked. So now it should load a different mesh. Yeah, so this is a sequence of much more recorded meshes. It's going to build up over time, just as a real session, and I can just move around, discover some tiles again, deactivate the visualization so it looks even nicer. Let's activate the coin generator again, set this, I didn't save this, set this to 1 again so it works. Great. And now I think I want to place Captain Doty. And, well, this looks good as well. I want to set this distance to the agent a bit higher, maybe, to 2. Still works, hopefully. Yes, perfect. And as you can see, we've got all these in-editor tools for you to iterate on your gameplay and make things easier to develop for you. So let me stop this scene, and we can go and have a look how this looks like in my backyard again. Sorry. This should be a video that now we see it. Perfect. And you see, it's still working. Looks great. It's fun to play. You can see occlusions work as well. I think Doty will run. I know this video. Will run behind the table. Great. And we just created our own game in the editor without ever deploying it. And then in the end, we try it out. So if you're interested in the Gameboard feature, we actually have the research team here. Saki Shinoda is going to talk a bit about the roadmap for our features that come out of research. And you can check it out today. If you are interested in any ideas, you can share them on Discord, see what other developers are up to. We're happy to get your feedback. Go on the forums, go on Discord, tell us what you want to build. And then I'm going to give it over to Amanda again. She's going to give us a recap, and after that, we're here for the Q&A.
Yep, before we go into our QA, thank you, Max. I just want to give a quick recap here. So you have seen a couple key features for improving your workflow in AR and building AR experiences in Unity. So we saw the Virtual Studio toolset with Kelly Cho, and we also saw AR Gameboard with Max. But this is just a couple of the tools that we offer as part of ARDK. So definitely encourage you to go to lightship.dev, check out the ARDK, lots of tools, example code, tutorials at your disposal for creating AR experiences. And then please join us on Discord. So like I said, this is where a lot of the action is. We really are looking for your feedback. Lots of ideas are being shared there. Prototypes are being shared. So definitely encourage you to join our Discord server. And then also during the summit, we've got a few talks on different areas of Lightship. So if you're interested in learning more about VPS, we've got a talk coming up right after this. We've also got a couple other talks over the course of the summit. There's going to be a few talks on shared AR and networking, as well as a few sessions like Max mentioned from our research and development team that are going to talk about future features that are coming. So with that, we can go into the Q&A. Yeah, come join me. Hopefully there's some Q&A. Yeah.
There's a microphone so everyone can hear the question. Sorry.
Eli here from Miami. The question I have is, could you have an existing AR project and then add Lightship capabilities to it, or do you need to start with Lightship?
So are you saying an AR app that uses ARKit, AR Core already?
Correct, yeah, that's in Unity, developed on Unity, and then add the functionality of...
Yeah, I think so, yeah.
Well, so right now, ARDK is not compatible with AR Foundation, and so you would need to start your, rebuild your AR parts of the application with ARDK APIs at least. But maybe, do you want to share more about our plans for
yeah, we are
maybe?
looking for deeper ways to integrate with Unity. But I think that you can take the existing project and, with some optimization, some updates, you could probably easily add ARDK services. It kind of depends on what you're trying to do. But yeah, ARDK is definitely made to come into existing projects.
Right.
Yeah.
Can I just add another question? Did I understand correctly? You could take literally a 2D image and it creates a mesh within the kit?
So are you speaking about the playback example that I had?
I think you were talking about either using LiDAR or using a
Yeah.
regular camera.
Have you used ARDK before? Did you?
Well, very little, but I'm here to kind of
No, sure.
totally get a
So we've
data
got a
dump.
technology that we call meshing that uses a set of images, and we estimate the depth if we don't have a LiDAR, or we have LiDAR measurements, and we incorporate those into a model of the world. So we use the tracking of the AR session from ARKit or AR Core, and then on top of that, we use our own technology to understand what the surfaces in the world look like. And we built this local mesh.
Great, thank you.
To be
Oh,
clear, yeah, can't make a 2D image into a 3D scan.
Yeah,
So that'll be
yes.
coming from a scan that's actually at that location.
Gotcha.
Yeah.
All right. Right, great. Thank you.
Yeah. Oh.
Sorry.
Can you integrate VPS and Gameboard so that your mesh that you've scanned can then become a Gameboard and like
Good question.
you're predetermined like this area is a
So we have the talk about the roadmap, upcoming features. I'm not able to say yes or no, but it's definitely one thing that immediately comes to mind to make it persist with VPS and to make the mesh already available to everyone at the same location. So this is definitely something we're looking into to make this feature even easier to integrate and immediately you get all the information. Does that answer the question?
Yes, and then a quick follow-up. In your example, there was a tabletop as well as the ground level. Is there a way to ask Gameboard, can you tell me which ones are elevated above the other ones? Like, give me a random spot on level 1 versus level 0?
That's also a good question because we are trying to build up a minimal functionality interface right now to add more in the future so we can incrementally add more functionality without breaking anything. And it is a feature that is driven by research. So we have a bit of this information in our model, but we don't expose it right now because we don't know if we want to change the model for a more efficient way. You definitely are able to use your own queries on top of what we do to just check if it's elevated.
Right. And then so you could say on your own, like this is a Gameboard, this is a VPS, get the unique ID, and then say this is Gameboard, this position is elevated higher than this one. So let's go ahead and spawn there.
This is definitely where we want to go, that you can set a set of constraints, like is it elevated, what size it is, we just saw one constraint was does it fit this amount of area, and we want to add more and more constraints like semantic constraints, is it the right semantic channel that I'm spawning on top of, but we're just not, as I said, it's coming out of research, we're trying to integrate it, we're trying to build more prototypes, we're definitely happy to show it in future iterations.
Right. I guess what I'm asking is, as a hack right now, should we go there and then find a Gameboard spot and then sort of remember that Gameboard spot and pretend it's random in the future gameplay?
We can definitely follow up on Discord what you will build with it. I'm really interested to see that, yeah.
Okay, cool. Thank you.
Asking the right questions, definitely.
Hey guys, great presentation, thank you.
Thank you.
I was just curious, is there any plans on integrating with Mars, or do you guys use Mars, or is that more of like a alternative to the ARDK? And what you guys' thoughts on that are?
Yeah, I mean, Mars offers some similar functionality as Virtual Studio. It's not something that is on our roadmap right now, but we're always looking at ways that we can kind of integrate more deeply with Unity. So it's, yeah, something that's on the table, something we would consider, but there's no plans right now to integrate with Mars. Yeah.
In terms of Gameboard, is there avoidance for virtually placed objects, or is it only for the real world right now?
Sorry?
Like, if you place virtual objects on the Gameboard and then you have a character navigating around, will they avoid the virtual objects too in the path calculations?
Right now, no.
And then would it be considered too heavy to use like use Gameboard to create the map and then maybe use Unity nav mesh on top of that, because they have kind of a experimental asynchronous building now?
Yeah, we've looked into it. It's definitely possible to build the Unity nav mesh on top of our green tiles or whatever you saw, like our game board. It's definitely possible to do that at runtime, but the Unity nav mesh generation at runtime is very limited in how you can tweak it to be more performant, to like cache the intermediate results.
Okay.
So you can play around with it. If you want to learn more of my research with it, can share some of it. But we're trying to get a deeper control over how we can build this and make it even better than the Unity nav mesh.
Awesome. And just one other quick question. Are we allowed to know what version of AR Core Lightship uses?
So Lightship will just use the most, it'll use the version of AR Core that is installed on your device. There is a minimum version of AR Core that is required, but otherwise, it's compatible with the latest versions.
Okay.
So.
I asked just because I had done some experimenting with using AR Foundations and Lightship at the same time. On iOS, there's no issues.
Yeah.
On Android, there's confliction with like if you're using AR Core 4, it's won't build out. It's like no, we can't play nice together. Cool. Thank you very much.
Cool. Any other questions out there? Okay, and if not, then thank you. We had a nice session with Kelly and Max showing off Gameboard and Virtual Studio. So appreciate everybody's time, and please come check us out on lightship.dev.
Yeah.